So this is the video of me explaining my calculations. This page was when I collected 10 velocities so I could get velocity average for the exit and entrance of the wind tunnel. And then here I calculated the cross-sectional area of the entrance and exit. You can see I set up the exit shape so that it would be easier to calculate the area, and then the fan's entrance, you can see from the video, is just pi r squared. So I have my area total right here. And then for my steps 2 through 4, or steps 3 and 4, so you can see I calculated the volumetric flow rate first. Q equals cross-sectional area times average velocity. So Q in should equal Q out, but the tunnel is of course not airtight, so I calculated Q in based on the cross-sectional area and the velocity average from the first paper. And then Q out, I know that Q loss is equal to Q in minus Q out. So you see I got my Q lost here in meters cubed per second. And then I did just a percent leak so that I could, when I calculated the mass flow, the percent leak should be the same if I do all my calculations correct. So it's kind of like a check. So then the mass in, mass out flow rates, and the mass loss. So the mass flow rate in is the density of the air times the volumetric flow rate. So in order to figure out the density of the air, I went on weather records for West Jordan at 1 a.m., which was when I conducted my measurements. The temperature was about 65 degrees Fahrenheit, so I converted that to Kelvin, and the average pressure over the past 2 weeks in West Jordan was 29.88 inches of mercury. Converted that to pascals, and then the gas constant for air is about 287.05 joules per kilogram Kelvin. And then I just used the ideal gas law here, and then turned N into mass over molar mass of air, and then volume into mass over density, and then solved for the density, and then got the gas constant over the molar mass, which is just the gas constant for air. And then the equation turns into density equals pressure over gas constant for air times temperature in Kelvin. So I did my calculations, got my density of the air for where I did my measurements, and then went and calculated the mass flows. Percent leak came out to 6.9%, and which is the same as volumetric flow rate percent leakage.